Hydrogen as green fuel. Hydrogen is a strong partner of renewable energies. Ways of hydrogen storage and utilization. In this diagram, we can see that there is a wind farm where the wind energy is getting converted into electric energy which is supplied to the grid. Now this grid is either directly supplying to the consumer, or in case of excess power in the grid, it is going to the electrolysis of water to generate hydrogen, and this hydrogen is either charging the cars driven by hydrogen, or it is going to the storage of hydrogen which is the underground cavern. Now this stored hydrogen as per need is either going to the consumer, or it is going to the charging the electric vehicle driven by hydrogen, or this hydrogen is going to the gas turbines, and as per need these gas turbines are generating electrical energy, and that electrical energy is directly going to the grid. So this diagram shows in nutshell the ways of hydrogen storage and utilization. So main points depicted in this diagram are large scale storage of hydrogen, utilization of storage medium for renewable energy, and then this is being stored in form of hydrogen. The utilization of surplus energy in the transport sector. In addition to use hydrogen for storage and load compensation, a further pathway for utilization of hydrogen will be its use in the transportation section. The current discussions on carbon dioxide reduction and the availability of fossil fuels shows that car industry is speeding up with their efforts to develop hydrogen powered vehicles. It can be observed that hydrogen propulsion in passenger cars is twice as efficient compared to today's internal combustion engines, and thus displaces conventional fuels and powertrains more efficiently. Request: it is hoped that this session is going to be useful to you. Please press like button. Please सब्सक्राइब दिस चैनल. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. In this diagram, we are showing B class of Daimler with fuel cells. Here we can see that in this car there is a lithium ion battery, there is hydrogen tank, there is fuel cell, electric motor, and the essential facts about this car is vehicle is constructed, fabricated and approved under serial conditions. It was tested by a turn of 125 days around the world with 30,000 kilometers. This car was fabricated with corresponding approvals. A tour with 30,000 kilometers around the world in 2011 demonstrated the applicability of this technology for general use. In this diagram, we are showing market segments of battery and fuel cell vehicles. Here in this diagram we can see the market segment for battery and fuel cell vehicles, and here fuel cell vehicles are hybridized. Very often electric vehicles with battery storage systems are considered as competitors to electric vehicles powered by hydrogen via fuel cells. But in reality, both types of electric vehicles complement one another. With respect to the market segments, this complementation was investigated in a coalition study as a European Union project. See the figure. In the segment of small vehicles and short annual ranges, battery vehicles are to be preferred due to the high efficiency of battery storage systems. In the case of bigger vehicles and longer ranges, more energy is needed on board of the vehicle, so that batteries are too heavy and hydrogen is needed even if a smaller efficiency due to the additional energy conversion of the hydrogen path is to be accepted. Here in this diagram we can see the energy management of a hybridized battery/fuel cell car. Here we are having the hydrogen cylinder. From this the hydrogen is going to the fuel cell. From fuel cell electric energy is coming out, and also we are getting heat from the fuel cell, which shall be used for heating the car under the cold conditions. The electric energy from the fuel cell is going to the electricity management block, and here we can see that in case of need this battery shall be charged, and in case of need this electrical energy stored in the battery shall go to the electricity management block, and from where it can go to the electric motor. The electric energy from the electric energy from the fuel cell can directly go to the motor, and the motor can receive electrical energy from battery as well as the fuel cell. And when the motor is to be stopped, the energy of rotation of this motor shall be converted. At that time this motor shall act as a generator, and the energy shall go back to the electricity management block, and the energy of stopping the electric motor while braking shall go to the battery as electricity stored. So here we can see that this electricity management block is playing an important role. It is providing electric energy in case of higher energy need, and while braking the car, stopping the car, the kinetic energy of the electric car shall be stored in form of electrical energy in the battery. This way, this system is conserving the energy. In general, a fuel cell car is hybridized by an additional battery. The main reason is the recovering of braking energy by using the electric engine as generator. The second reason is the extra power supply in the case of peak load, and the third reason is use of waste heat of fuel cell for preheating the car at low temperatures. For this purpose, a fuel cell can be started sometime before departure. The electricity is used to fill the battery and the waste heat is used for preheating the car. When driving, the electricity is withdrawn from battery and fuel cell so that enough heat is available for the car, and the battery is empty again at the arrival, so that the processed car starts again for the next ride. By this way, heating and preheating of the car is available without loss of range. In figure attached, it was shown that in future significant amount of energy from biomass will be available, preferably from biomass of first generation without competition to food production. For the use in mobility, this biomass will mainly be converted to bioethanol or biodiesel. Both liquid fuels will be used in internal combustion engines with typical Carnot-like efficiency curves. Efficiency shall be depending on the load of the engine. In this diagram, we can see the comparison of efficiencies for a fuel cell system and internal combustion engine. For fuel cell, we can see that the maximum efficiency is in the low power range, and for internal combustion engine, the maximum efficiency in the high power range. So in the low power range, we are having the passenger cars, and little above that we are having bus and trucks. Increasing combustion temperatures are related to increasing efficiencies and increasing power densities. The maximum of efficiency for a fuel cell vehicle is in the low load sector, in the typical operation mode of passenger cars, urban buses, and small delivery vans. As a consequence, fuel cell systems are mainly suitable for these vehicles, whereas internal combustion engines with biofuels have highest efficiencies, which are mainly operated with high load, heavy trucks, motor coaches, airplanes, big ships, etc. Both fuel types, liquid from biomass and hydrogen from renewable electricity, are needed to reduce carbon dioxide emissions in mobility, but preferably each one for its best efficiency range. Summary: hydrogen makes renewable primary energies ready for basic power supply. Hydrogen makes the energy transition affordable due to its energy storing capability and a lot of further applications. Hydrogen introduces renewable energies into mobility. Hydrogen enables electric vehicles to reach long distances. Hydrogen makes mobility carbon dioxide free. Hydrogen and fuel cells are strong partners of renewable primary energies and are essential elements for the energy transition. Acknowledgement: most of the material for this lecture has been sourced from the following research article. The name of the article is given here, and this article is available online at this given address. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा.